don't want to move it.
Okay, we're going to talk about distributive property. Again, this is something that we're going to need in order to solve equations as we move forward. A couple of things that you need to be comfortable with when we start doing distributive property is obviously multiplication, but also combining like terms. This is where combining like terms will really come into play when we start solving equations and solving for variables and so forth. Alright, so the textbook defines distributive property something like this. Basically it says A times B plus C. Okay, B plus C are in your parentheses. We call this a binomial, which we'll talk more about that later. Equals, okay, the same thing as A times B plus A times C. So A times B plus A times C. So how do we get this? Okay, well, again, this parentheses indicate that we're doing multiplication. We're multiplying this A times everything inside the parentheses. So the way I get this is basically by arrows. And I'm going to require you to draw arrows whenever we get to doing this on our papers on a regular basis. So basically I do this, A times B, and then A times C. Here's your arrows. A lot of teachers will call this sharing. This is our process of sharing. Again, it's just multiplying across everything so that way you get the same answer. Now again, this is a textbook definition, and what that means is it's a little harder to understand, but I want you to see this because you'll see this a lot in college. But we'll go ahead and let me give you some numbers as an example. Let's say we have 4 times 3 plus 2. Okay, well if we do this problem like we would normally do it, if we follow the order of operations, we would do 3 plus 2 is 5. So then you would have 4 times 5, and 4 times 5 is 20. But if we use our distributive property, we have 4 times 3 plus 2, okay? And then over here, you would have 4 times 3, which would be 12, and 4 times 2, which would be 8, and 12 plus 8 is 20. And again, this is the same thing as 4 times 3 plus 4 times 2. Okay? It works out the same, and you're probably wondering to yourself, why would I ever want to do this when this seems a lot easier? And it is a lot easier. But normally we wouldn't use distributive property for these types of problems. So let me give you a more realistic reason. There's actually 2 reasons why we would use distributive property. One is it would help you with mental math, and 2, if we have variables inside these parentheses, it makes a difference. So let me give you an example of the mental math part. So let me erase this. Okay, let's say we want to calculate 3 times 16. Well, most people, if you ask them what 3 times 16 is, they can't give you an answer right away out of their head. And some people can't even figure it out in their head at all, let alone do it quickly. But if I said, okay, let's break this down. 3 times 10 plus 6, I could probably do that in mental math a little easier. So I would do 3 times 10, we know that in our head is 30, and 3 times 6, which we should know in our head is 16, I'm sorry, it's 18, and then 30 plus 18 is 48. So basically we took 30 times 16, which we may not know right off the top of our head, and we made it easier by saying, okay, well 3 times 10 is 30, and 3 times 6 is 18, 30 plus 18 is 48. We did that in our head. That's kind of a mental math approach. You can do that with any type of number that if you can break it down and then use distributive property, it might make some mental math problems a little easier. That's one use for it. But our primary use for the distributive property is when we're solving equations. Okay? Let's say we have this problem right here. 3 times x plus 4 equals 12. We want to solve this equation. Now there's a couple ways to go about doing this, but the first one I want to show you is distribution. In fact, the only way I want to show you is distribution today, and then I'll show you some shortcuts later on as we move through the weeks and we get better at distribution. The first thing I need to do is I need to get rid of these parentheses, because distribution, like we talked about in the bell ringer today, helps you get rid of parentheses. So I'm going to get rid of the parentheses by multiplying 3 times x, because I can't add x and 4 together, because they're not like terms. So I can't add x and 4 together. And so what I would have to do is to get rid of the parentheses, multiply 3 times x and 3 times 4. I only multiply the number touching the parentheses times the stuff inside the parentheses. I'm not going to take this 3 to the 12. Besides that, it's already on the other side of the river. We don't have to worry about it. Okay, so 3 times x is 3x. You can, and that's one thing we haven't talked a whole lot about in classes, but you can multiply and divide unlike terms. You cannot add and subtract them, but you can multiply and divide unlike terms. So I'm going to take 3 times x and get 3x. 3 times 4 is going to give me 12 equals 12. Now, this is just a simple two-step problem that we've been working on for the past several days, so we should be able to solve this with no problem. Again, we start with our adding and subtracting. So we subtract 12 from both sides. In this case, this cancels out the 12s. Positive 12 and a negative 12, zero pair, they're gone. Bring down what's left, which is 3x. Don't forget to put your equals. 12 minus 12 is also a zero pair. Okay, just worked out that way, so I have 0 here because those cancel out. Now I got to get rid of this 3 away from my x. To get rid of the 3, it's being multiplied here. I divide both sides by 3. This cancels, leaving me with x equals 0 divided by 3. If you plug that into your calculator, is 0. So x equals 0. So we've just taken and applied distribution to our equation solving process. Distribution is going to be one of the first things that you do before you get into solving equations. If you don't do distribution first, there's a good chance that you're going to mess something up. So you need to distribute first. That would be like step 1 if you have a regular long equation. Let's look at another example. Okay, let's say we have 2x plus 3 times negative x plus 4 minus 2 equals 8. Okay, significantly longer problem here. Now, if you notice here, we have parentheses in there. I just said a second ago, the first thing we want to do is get rid of those parentheses. So we need to distribute. We've got to apply the distribution property here. Now, when I start to work this problem, it's very important, and this is why I've been stressing organization, because it's very important you organize your work so that you don't mess up anything or forget something. So the first thing I'm going to do is I'm going to look at this and say, okay, here's my parentheses. Here's a 3 touching my parentheses. I need to distribute this first. Actually, I'm going to turn this into a positive 2 for this example. So if I distribute this first, I'm going to draw my arrows, and that's going to be required for your work, is to draw your arrows to kind of get used to the idea of what you're distributing. Am I doing anything with this 2x? I'm not, right? So I'm going to bring it down, and I'm going to create 2x, and then I'm going to go ahead and work out my distribution. 3 times negative x, it's like saying 3 times negative 1x is negative 3x. 3 times 4 is a positive 12. And then I do not distribute back here. It's only the stuff inside the parentheses. So did I do anything with this 2? The answer is no. I just bring down the 2. So it's plus 2 equals, of course, I haven't done anything with the 8 yet. All right, now, this is where combining like terms becomes very important. I have like terms I need to deal with. Okay? The first one, and if we do the circle box triangle method, that's fine. My first term is 2x. I need to find anything that has a singular x value in it. Well, I have negative 3x. In this case, they just happen to be right next to each other. Those are the only 2 like terms with x's that I have right now. So 2x minus 3x gives me a negative 1x or a negative x. I'm done with these. Okay, if I look here, I got to look at what's happening here. Here's another set of like terms, a positive 12 and a positive 2. That's why I boxed those. 12 plus 2 is a positive 14. I'm done with those. I've now used all my terms and I've simplified it down so that it makes solving my problem easier. Of course, my equals and my 8 come down. Now I'm into a part of my equation. I should be able to solve this easy. At this point, you should be able to solve these equations pretty simply. So I'm going to subtract 14 from both sides because I got to do my addition and subtraction first. This is going to eliminate my 0 pair, positive 14, negative 14. It eliminates them, bringing me with a negative x equals 8 minus 14 is negative 6. Okay, one thing I don't want to do is I do not want to leave a negative on my variable, ever. So I need to get rid of this negative. Now, I'm going to show you the way mathematically you're supposed to work this out. Again, if you remember, this is basically like saying negative 1x. So if I do this mathematically, what I would do is I would divide, because it says negative 1 times x. I divide both sides by negative 1. These cancel, leave me with x equals, the negatives cancel, 6 over 1 is 6. Now there's a shortcut that I haven't showed you yet, and I want to show it to you now. If you want to do it, you're more than welcome to do it. If you don't, it's fine too, whatever way you prefer. If I end up with negative x equals negative 6, I can just simply take this negative sign, throw it to the other side. When I throw that negative sign to the other side, it changes the sign on the other side of the river. When I change the signs on the other side of the river, this negative's gone because I threw it over there, so it becomes x. This negative changes because I threw a different negative over there, and it turns into a positive 6, or x equals 6. Same solution. This is just kind of a shortcut versus the dividing by negative 1. Okay? I'm going to give you one more quick example, and then I'll have to show you one more thing. I know I don't want to get too long. Okay, let's say you have this problem right here. 4 plus x minus 3 equals 8. Okay? If we do this problem, there is a thing called reverse distribution. Okay? You can distribute backwards. For example, I can take this negative and throw it back here. Okay? If I do that, what happens is a negative times 4 is negative 4. Negative times x is negative x. And then, of course, I'm just going to take this 3 out just for the example. I'm sorry. I just want to do it like that, just for the example, because I don't want to confuse you with another number right now. So this becomes negative 4 minus x equals 8. If I solve for my x value, first thing I want to do is get rid of this 4 that's out here. Yeah, I don't want to move the x, because if I add the x to both sides, all I'm doing is putting the x on the other side. I don't want to do that. I got to get rid of this negative 4. So I'm going to add 4 to both sides. This cancels. Those are 0 pair, negative and a positive. Those cancel out. Now I have negative x equals 8 plus 4 is 12. Again, I don't want a negative, so I'm just going to throw it to the other side. It changes my sign, so x becomes negative 12. And if I want to check my answer, what you guys should get in the habit of checking your answer, the way I would check it is basically put 4 plus my x value is negative 12, and then the negative sign out here, which basically turns everything negative or opposite, equals 8. So if I work this out, everything should equal 8. So 4 plus a negative becomes 4 minus 12. 4 minus 12 is negative 8. But over here I have a negative sign, equals 8. Negative 8 and the negative sign, those cancel out, become positive 8 equals 8. So that does check out. Now I know this looks weird, and this will come up from time to time. Not very often, but it will come up from time to time. So be prepared to solve that if that ever does show up. Okay? All right, so that's all we're going to talk about with distributive property today. If we have time tomorrow, I'm going to show you something about what's called point slope, the point slope formula. If you have time and feel the need, you guys can look it up. It's called point slope, form of a line. That is our next topic that we're going to discuss if you want to get ahead. It's going to go, we've already learned about one form of a line, which was the slope-intercept form, y equals mx plus b. This is our next form that we're going to discuss, which is point-slope form of a line, which is the same thing as y minus y1 equals m times x minus x1. So you can see where distribution is going to come in here, so that's why that's very important. Okay? All right, so watch this video. I'll see you tomorrow, and we will do our distributive practice tomorrow. Thank you.